Ao final de uma operação, um AUV é capaz de retornar a um local anteriormente programado. Os submersíveis podem ainda ser usados com finalidades turísticas e proporcionar verdadeiras aventuras submarinas, que antes só seriam possíveis nos filmes. Um exemplo desse tipo de expedição é a observação de naufrágios históricos. No entanto, também é importante citar a tragédia ocorrida com os tripulantes do submersível Titã. O fato nos mostra o quanto é preciso aprimorar a tecnologia para oferecer cada vez mais segurança. Com o objetivo de contribuir para ampliar o know-how a respeito dessa sofisticada tecnologia, o Centro de Excelência para o Mar Brasileiro tem o prazer de promover este webinário. Através de diversas palestras e debates, será apresentado o que há de mais recente a respeito das pesquisas, desenvolvimento e uso desses veículos no Brasil e no mundo. O Cembra continua acreditando que divulgar e ampliar o conhecimento sobre a importância de tais veículos é fundamental para a pesquisa e exploração do mar, pois essa é uma forma de afetar os tomadores de decisão que podem contribuir para tornar o mar brasileiro mais conhecido e promover o aproveitamento de seus recursos de forma racional e sustentável. Vamos juntos explorar esse tema que é tão importante para o futuro do país. E quem sabe estará no mar profundo o futuro da própria humanidade.
Bom dia! Sejam todos muito bem-vindos, muito obrigada pela presença.
Good morning, welcome everyone. Thank you for being here this morning with us, for connecting to the second day of our agenda on the second international webinar on submersibles, Braving the Deep Sea, the Conquest of the Future, an event promoted by Cembra, the Center of Excellence for the Brazilian Sea. If you were not here with us yesterday, I'm Claudio Bertazzo, I'm the MC of this event, and it's a pleasure to be here with you throughout this event. I'd like to reinforce that participation certificates will be sent only to those who have registered in the event banner on the right side of the screen. If you're watching it in Portuguese or original audio, simply click the icon, click here, and register. I please ask you to answer our brief questionnaire that will be sent via email to everyone registered. It's very important for us. And please remember, if you don't want to listen to the simultaneous translation, click in Original Live. I'd also like to highlight that everyone can feel free to ask questions interacting through the live chat. Yesterday guided us in the right direction to reach our goals, which is contributing to expand the know-how on the sophisticated technology, submersibles, and to make the subject stand out before decision makers, and to continue with this valuable agenda on the second international webinar on submersibles, Braving the Deep Sea, the Conquest of the Future. We are honored to invite the moderator of the third panel, Submersible Development and Use by Institutions and Companies Abroad, Professor Dr. Carlos Levy. Welcome, Professor.
Good morning, all. I'm very glad to be here hosting this third panel of the Cembra's webinar on submersibles. I'm very pleased to welcome and thank you our speakers who accept our invitation to discuss the international development and use of the submersibles by research institutions and commercial companies abroad. We are going to start our discussions inviting Professor Eduardo Silva from Inestec, our research institute in Portugal. Professor Eduardo Silva got his PhD in electrical engineering and computer from University of Porto, Portugal. He is lecturer at the Polytechnic Institute of Porto and at the Superior Institute of Engineering at Porto, Portugal, being also researcher at the Institute of System Engineering and Computers Technology and Science, INESTEC. And to talk about the research and development of the INESTEC submersibles, the Trident project, I have the pleasure to call Professor Eduardo Silva. Please.
Thank you very much. I go to share my presentation. Okay. Let's see if work well. Yeah. First of all, I want to thank the organization to invite me to participate in this talk in this morning in this discussion. It's a pleasure always to be with my colleagues and talk about robots. And I go straight to the point. I go to talk about with the 3 or 4 robots we are developed in the past, and I go to present our most promising project and in deep water for deep waters. Okay. First of all, INESTEC are developed several robots for the sea, not only for the sea, but underwater robots. And the Trident project is a project financed by European Union. And the main idea is to develop technologies for monitoring industrial activities in sea. Okay, the idea is to build all systems for the monitoring, and we go to show some our solutions we are developed in the past, and I will talk about some details on that. Okay. I don't know if you are seeing my screen, because if I understand, okay, I have some delay, but we develop, normally the people think we are develop toys. And when they come to our lab and see our robots in operation, normally the people think, okay, this is a team develop toys, but it's not real, it's more than toys. Okay, we are child, and we love a lot to develop our robots, but the functionalities of our robots have in mind some requirements. Okay, and I need to explain one thing: we develop tools. We are not from geology, we are not from biology, we are not from environmentally engineers. We are people develop robots, and robots adapt to any type of the problems or any type of solutions. And we develop aerial, land, or water robots. And we are not only develop robots, we also sometimes we develop sensors. Normally we are more engaged we develop in terms of the science and research. Our main goal is the perception. Always our robots have in mind our scientific developments, the perception systems inside of the robots. Okay, I go straight ahead to the point. I go to talk with some our stars, and not about applications, but I go to tell the story. EVA is one of our most prominent robots. We start to develop EVA because we have a very important project. The name is VAMOS. If you go to the internet, you can spell Vamos, you can find the web page about the project. And the project is exploitation of underwater mining inland, in open pits. In Europe, exist more than 2,000 open pits mines abandoned. Before we go to try these technologies in the sea, we can apply these technologies in land, because you have a lot of the open pits abandoned. And normally when the open pits are abandoned, the table of the water rise. And this is normally are a big lakes. And now, taking into account the new tools and the new technologies for mining and processing, some mines are abandoned because the ratio of the mines are not good. But now the quantity of the metals are good enough to return and mining again. And instead to take the water out, to take the water for the mine and come to the classic techniques, we have a project to show is possible to mining in underwater. And EVA is not a mining robot, but is a mining satellite robot. This robot help the mining machine in operation, because give position and give and modeling in real time the ore and the morphology of the mine, and give to the operator the perception of the environment around the mining machine. Okay, this is an autonomous. EVA can work autonomously or remotely, because you can the energy is in the robot, but you can attach an umbilical, electro-optical umbilical to give the information in real time to the operator, even if the EVA operates autonomously. Actually, in meanwhile, EVA have a lot of devolutions, and the last mission of EVA is we have a mission to work with people from biology to monitoring one vulnerable one area to see if it is possible fish again, because the area are in the past a lot of saturation in the trolling fish, and we need to see if the ground of the sea recover from the last fishing seasons. And we do a lot of the kilometers below, near to the ground of the sea, less than 2 meters, to take image with capacity to detect the fish, measure the fish, the quantity of the fish, to help the people in some biology in reports, to give information to the European Commission to decide if the area is open or not open to the fish, the fishermen again. And the EVA, you have some details in the screen about the EVA, but you can find EVA also in internet or some articles. But this is a very important robot for us. In this moment, the depth rating is not 1 kilometer, is 1.5 kilometers in this moment. Every season we go to rise the capacity we replace some sensors and we replace some components to limit the depth rate, but actually in this moment is 1.5 kilometers. The other robot is a very old robot, still using this robot to support the underwater operation. This is a ISV. This ISV is the first robot we develop autonomously for the sea. Normally, this is a general purpose, and we use this robot in different type of missions. For spread bacteria in the sea, to heat the oil, or for monitoring the water, or for do some underwater mapping. And this is a very old robot, but every season we improve this system. The main, you can see the sensors. The payload is very high payload. I can use all the sensors in the payload, but the most important sensor is multi-beam echo sender, and also for the sub-bottom profiler if I want to measure below the ground of the sea. Okay. The applications are a lot. You normally use this robot in all our projects, because if I go to work with biology or geological people, always they need the functions of the wash. Another and very important robot is the turtle. Turtle is a robotic lander. It is a mix between lander and a robot. Portugal is very depth, and operated landers is very expensive, because I need a big boat or a big ship to operate the traditional landers. And sometimes I need only to move the lander from one place to another place, 1, 2, 3, 4, 5 kilometers. And we decide to develop a robotic lander. Okay? Normally, if you go to the EVA is a AUV to move in the water column. Turtle, I can maintain the turtle 2 months in one place and underwater, but after 2 months, I can move the turtle 2, 3, or 5 kilometers to the other position and stay and monitor it again. Okay, if you go through the characteristics of the turtle, you can see the payload. I can go to 300 kilos of the payload. It's possible to install more than 300 kilos of the payload. The lander can move in the water column to move the position, and also can come into the surface for cleaning or for maintenance without needing a big ship. I only need a small rubber boat to cleaning or for replace or charging. In this moment, this robot can be charged underwater from a buoy. In the last month, we have a demonstration in Portugal to show the capacity of this robot to come near the surface and below the surface, attached to one buoy with a charger, and charger without coming to the surface and go down again. And this is our robot line of the robots we want to continue to develop, because they have a lot of the civil applications or military applications. Until now, the most promising application is to recording acoustic sounds in the sea, because the people from biology want to listen the noise and underwater. And the last missions of the turtle is to stay more than 1 week to listen in some areas and recorder, and when after sometimes coming the surface and the people download the acoustic sound the acoustic file, and send again again to the deep sea, the turtle. Another important vehicle we develop is for catching or finding the nets. We have a project in Europe, and the fishermen put some tags in the nets, and if they lose the nets, we can find the nets in the sea, and avoid the plastic in the sea in simultaneous, and sometimes recover totally the net. And we develop the iris. Now iris go to the next week, go to Arctic too, because we go to do experimentations with a DNA sampler there to catch DNA in the Arctic. But it's a very only the weight of this robot is only 27 kilos. We can launch from the boat with small boats, and we can find some operations in video in some servers in the internet. But
you have 5 minutes now, right?
5 minutes, okay. I
yes.
go straight to the point. This is a very important robot for us. This is Ushis One Neo. This is a robot we developed for explore underwater minings in tunnels. And this robot have a record in the natural caves in the land. They do the world record and do the most deepest dive in natural caves inland is done by this small robot, this spherical robot, and you can find a very beautiful dog in the 27 minutes dog in this location in YouTube, and you can see the process to build the robot and the dives of the robot in the caves, and the world record in the Arnica abyss in Czech Republic. And we are very proud of the result we have in this robot. But this I want only to show these technologies because I go to talk about the project. They start this year. This is a 5-year project, and they start now. Is develop technologies for monitoring the impact assessment of the sea mining exploration and exploitation. Okay. The approach of this project is very holistic. We have in the project people from biology, people from the environment, people from geology, and this team give us people from technology the requirements they need for do the monitoring of the impact of deep sea operations. And this is a very big consortium. It's more than 24 partners, and Dinesh is the coordinator of the project, and we are the guy to go to develop the technology. The robots are not yet ready because we start now, but our inspiration is in our previous robots, okay? And but these robots must perform and give the information in the standards to allow the information in catching in real time or semi-real time directly to the servers like ModNet servers. Okay, the concept is very easy to understand. We have our concept is to build a nearby monitoring to nearby to the operation, a middle field and a large field. In the large field we go to use gliders, but in near field we go to develop new sensors and new robots to catch in real time the impact of the operations in deep sea. Okay, if you see in detail some image, we go to put sensors in a mining machine, we go to build a mothership robot to deploy landers and catch the landers, because the horizon of the mining is rolling, and we need every day to move the structure of monitoring in deep sea. But pay attention, because in this year our first results go to appear, because now we are defined the baseline, the variables I need to measure to fulfill the baseline. And in the next 3 years after that, we go to develop the technology, and in the last year we go to perform the tests in the Tropic of the Cancer. We choose the Tropic of the Cancer mountain near to Africa to test the results of our technology. Okay, but the most important thing is the underwater communications. You have a company to develop the internet for the deep sea, and changing the sensors and changing the robots to adapt to the mining operations, to observe the mining operation, and also to try some mitigation for the impact of the deep sea. But you have my mail or email of the event. You can find in internet also the web page. We can contact with and follow our work in the next 5 years. And thank you very much to listen to me. And I'm open if you have any questions in the end, or when you want, or send me an email. Please feel free to contact me. Thank you very much, Levi, for that.
Thank you very much, Professor. Yes.
Let me see if I can stop the share.
Thank you very much for your clarifying talk. Showing how Europe is a good example of cooperative work. They are doing quite well in this kind of initiative. So you showed us your long experience.
I can tell you one thing. In our advisory board exists one Brazilian organization. It's a geological Brazilian organization, belongs to our advisory board and follow also on our project. He's not an actor, but he's one advisor to us. Okay.
Yeah, thanks. I think it's important to strengthen this relationship, because you have a lot to do in the deep water. Thank you very much. And in the end, during the debate, you have the opportunity to talk a little bit more about it.
I'm here. Okay. Thank you.
Next, I have the pleasure to call engineer Laila. Sorry, I made a confusion. Professor Wensheng Kui. He is at the present. Professor Kui holds the position of professor at Westlake University in China. He has got his PhD from Bristol University in UK, and worked during quite a long time at China Ship Scientific Research Center, well-known research center in China. He was appointed for the Shangshan Professor Chair at Shanghai Chittong University, and also worked at Shanghai Ocean University. So Professor Kui will show us his long experience in submersibles, including the project leadership of the managed submersible Zhanglong, and also the Rainbow Fish Challenger Deep. To talk about the introduction to the submersible development history in China, I have the pleasure to call Professor Kui.
Okay, thank you very much, Professor Levy, for your kind introduction. Ladies and gentlemen, it is my great pleasure to have this opportunity to make a presentation in this second international webinar on submersibles. Yeah, the topic is the historical introduction on the submersible development in China. And basically, I will divide the introduction in 5 parts. After the introduction, we'll go to the early period of partnership and a quick development period, and also the challenges for ocean depth period. And also briefly mention some future directions. As you know, the conflict between population, resources, environment in the 21st century made the ocean the strategic space to realize the sustainable development. So in order to exploit the ocean resources, a fundamental understanding of the complex ocean process is necessary. And various underwater submersibles are the main working force for the research fleet. So this is a picture shows a very comprehensive installed ship. And this slide shows a historical development of the famous submersible internationally. And everyone knows that the concept was from the biosphere in 1930s. And then came to the first manned submersible in 1948, and just reached to the Mariana Trench in 1960. And afterwards came to the, I call it the second generation submersibles. And now I think second generation submersible has reached to the 4 ocean depths. And for the submersible, basically it can be divided into manned, unmanned, and each can be subdivided into several categories. So the purpose of this presentation focused on the development history and current status about the Chinese development on various submersibles. And in China, actually, the start of the submersible is quite early. The earliest submersible developed in China was a deep submarine rescue vehicle named 7103, which indicates that the project was started in March 1971, but the project was finished in 1987. And that project was jointly developed by Shanghai Jiaotong University and the China Ship Development and Design Center and Wuchang Shipbuilding Industry Company Limited. And from 1981 to 1985, because in China, the project was covered every 5 years. So CSRC, as I mentioned, my former working organization, developed the first atmospheric diving suit, we call it ADS, and then the QS-01 for the Chinese Navy. And the next 5 years, they developed the second one, QS-02. And both of them are 300-meter diving depths. And in the year from 1991 to 1995, Harbin Engineering University, in cooperation with CSDDC, they developed another manned submersible called the Yi. And this was a manned submersible of 200-meter diving depth. And actually, this one worked in a deep sea lake, not in the ocean. And from 1996 to 2001, CSRC also developed a rescue bear of 200-meter depth. So all these belong to the category of the HOV. The intent of the remotely operated vehicle, ROV, in the late 1970s and early 1980s, and Shenyang Institute of Automation, SRA, of the Chinese Academy of Sciences, in cooperation with SJTU, they started to develop the first ROV named HRO-1 in China. And this was completed from 1981 to 1985. And this was also a prototype ROV of 200-meter depth. And afterwards, from 1986 to 1990, SJTU continued to develop ROV HR-2, while SRA developed their own ROV called the Recon 4. And both of them are also 200-meter depth. And after that, SIA was focused on the development of AUV, and they more or less gave up ROV, while SJTU continued on the development of the ROV. From 1991 to 1995, CSSRC also finished the development of a 600-meter ROV called the ATA4. It was successfully finished the sea trials, but also not put it into service. And for the AUV, the first AUV developed in China was called the Explorer, and the maximum diving depth is 1,000 meters. And nearly the end of the project, then the SIA, CSRC, in cooperation with Russia, and then developed the first 6,000-meter AUV, named the CRO-1. And after that, continued the second one, CRO-2. And so we had, during that period, had two 6,000-meter AUV. In the similar period, Harbin Engineering University also started to develop AUV for military use, and they named the Zhihai series, Zhisui series, Zhisui 1, Zhisui 2, Zhisui 3, something like that. And so in this early period, actually 4 organizations, they have formed the special divisions focused on the development of the submersible. So basically, these are the CSRC, which is a strong point, is the HOV, SJTU, with a strong point ROV, and SIA is the AUV, or commercial AUV, and HEU is the military AUV. And these are the different submersibles developed in the first period. So actually more than 10 submersibles developed, but all these are the prototype, not actually can be used in practical applications. And in the 1990s, China Ocean Mineral Resources R&D Association, called CEMBRA, they urgently needed various submersibles to explore the international oceans. You know, they are on behalf of China in the ISA, International Seabed Authority. So based on the experience of the previous first stage, then CEMBRA sponsored SJTU in 2001 to develop a workable ROV of 3,500 meter depth and Heilong. And at the same time, and CEMBRA successfully persuaded the Ministry of Science and Technology to fund the project to develop the deep-manned submersible, 7,000 meter depth. So afterward, the named JULY19. And I'm actually the project leader of this JULY19 project. And from 2011 to 2013, SIA was tasked by the CEMBRA to develop another usable 6,000 meter class AUV, and this was named as a JULY1. And the success of the JULY project actually represents a sort of a milestone achievement in the development of submersible in China. As you know, you have seen, before JULY, the submersible developed is not usable. It's just a prototype and training the people. And JULY was carried out the 4 sea trials, and it shows it can work in the design depth. All the functions are good. So this achievement was also reported by Nature and Science, and it is said that China now joins an exclusive club of countries that have capable of achieving human access to the deep sea. So in the period of 2008 to 2016, 1 submersible in each category of AUV, ROV, HOV, respectively, was sponsored by the the Ministry of Science and Technology. And for this submersible, the depth is 4,500 meter depth, not the very deep. but the main requirement emphasis was on the 90% of equipment must be built in China due to the technical blockage. Previously we made in the development of JULY19 deep submersible. So there we finished the sea trials in 2014, 2017, 2016 respectively. And they named Hema for ROV and Shanghai Yongshi for HOV and Qianlong 2. And after that, then the interest in the military science and technology actually focus on the 4 ocean depths. So from 2013 to 2021. And by judging the trend that most were sponsored the 11,000 meter submersible in the period 2016 to 2020, and the CAS set up a new research institute to develop the 4 ocean depth landers, ARVs, HOVs. So-called ARV is a hybrid AUV and ROV under the leadership of Dean Kang, and he is the advisor of JULY19 project. And so their team successfully finished the sea trial of Hydro HRV-1 and Tianya Hydro 2 landers in the Challenge Deep in Mariana Trench in June to August 2016. But the ARV-1 was lost in the operation in the next year, like it means in the 2017. And at the same period, when I finished the JULY19 project, I joined the Shanghai Ocean University to set up the Hydro Science and Technology Research Center to develop the movable laboratory for hydro zones, which include 1 HOV, 1 ARV, and 3 landers. So I call the whole system, including a special mothership, and I call all the system as a movable laboratory. And our 3 landfish landers, series landers, also successfully finished the sea trials in December 2016, but due to various user problems, the maximum depth of the ARV was only reached 6,300 meters. So that's ARV didn't very successful. Was not very successful. And after that, also use supply funding to build the first mothership Zhangjian in 2016. And after that, we built another specific mothership use pillar funding for the Senko. And due to I didn't get the funding for the manned submersible, so I actually joined the research university, get some further funding for the second generation 4 ocean depth landers and the unmanned submersible. So I developed another 2 unmanned submersible and 2 4 ocean depth landers. Second year, also a 4,500 meter float buoy. And also we intended to build up a new concept, 6,000 meter HOV, and we finished the manned cabin, but other funding have not been obtained yet. And other organizations like Tianjin University, they have developed the Haiyan 4 ocean depth glider, and also HEU developed the 4 ocean depth AUV Wukong, and SJTU developed 4 ocean depth ARV for the Siyuan. In terms of the technology challenges, such as I take an example for how to develop the 4 ocean depth manned submersible. Basically, you can divide it like into several subsystems. Here, I divided the manned submersible into 7 subsystems, like the overall performance and layout, structural system, mechanical system, electrical system, and control system, acoustic system, and live support system. So then let each deputy chief designer to identify the key problems, issues within each subsystem. Then overall, in terms of this technical challenge, we can divide into 3 levels. The first level is just how to do the overall design of the submersible to reach the mission requirement. And the second level technology is basically how to design and manufacture equipment Actually, this problem can be like tasked to the manufacturer of the equipment, not necessarily to be solved by the design team. And then the design team is how to do the assembly and the sequence of the submersible. So after the finish of the journal project, we actually master the technology of level 1, level 3, and then in cooperation with the people manufacturer of level 2. Actually, we can develop the 4 ocean depth landers, submersibles, or something. And this figure shows currently the famous submersible owned internationally on the left side, and those submersibles owned in China. Actually, in China now, we own actually more or less half of the international submersibles for the deep sea, for the deep seas, manned, unmanned, and we have every type of submersible can reach to the 4 ocean depths. And in terms of the future directions, I actually divided the technology into 3 generations. And the first generation is manned submersible. And its main characteristic is the float chamber filled with the gasoline for buoyancy, so which are very large, the gasoline bag. And also the separate pressure chamber to hold the crew. So this is a main cabin. And this kind of submersible is very bulky, very heavy. So there's no self-moving ability. So the second generation of underwater submersible first from the manned, then to unmanned, and to hybrid. And the main characteristic is that we use a solid buoyancy material for the buoyancy. So like all this the solid buoyancy. And also use a silk high strength alloys or steels, titanium, aluminum, or something to reduce the weight. So the maneuverability, self-maneuverability much improved. This is called the second generation. But if we compare this performance of second generation in terms of the fish, there are still a big gap can be identified. So the next generation, we need to learn from fish called bio-inspired propulsion system. It should have a high speed, high maneuverability, high efficiency, and low environmental disturbance and low noise. And this slide shows the historical research history of the robotic fish. Actually, the concept was proposed in mid-90s for the robot tuna from a professor near MIT, and then several other universities like Cambridge University or Essex University and Nanyang Technology University, and several other universities. They have make quite a significant achievement, and several universities from China like Zhejiang University and Northern Western Polytechnic University, etc. They are also listed in the category. And so when Western University, when I started the new team, I joined the Western University in 2018. And which fish I should have started after comparison and historic survey, then I decided to use mantle lamp as the first type of fish we try to develop, considering because of this wide pectoral fins for propulsion, and the pectoral fin can undergo complex deformation and also high motion efficiency, good maneuverability. And so the main technology challenge in the design of the robotic fish basically included how to solve the fluid structure interaction for flexible and deformable materials. And also we need to use 3D printing manufacturing technology. Nowadays, more and more popular. And also artificial intelligence technology, much improved. And we need to consider use the distributed energy and sensors. And then similar as the multi-dimensional design from macro scale to micro scale. Now a lot of nano manufacturing technology has been also included. So this is a submersible for robotic fish. Is the first submersible developed by our group since I joined. And I asked the team, we need to have the feature of high throughput observation system and integrated package for the integrated package and convenient maintenance and also efficient biometric production structure needed to be included.
Please, Professor Kui, you have 5 minutes.
Yeah,
now.
okay, I'm more or less okay. And another feature is like high stability and good load capacity and high stability distributed intelligent control system and with the comprehensive alert detection and redundant emergency system, etc. Installed. So we about to spend several months to finish the design and then started to order the equipment and then do the testing of each of the subsystems in the pressure chamber. And then after that, we do the assembly of the submersible in our own workshop. And after that, we do the open water tank test first. This is the open water tank test is also located in our own lab. And after the problem detected, then we improved. We go to a leg test. And in Hangzhou, there's called the Southern Isolate Lake, the maximum depth of about 60 meters. So we hired a ship to do the leg test, find the further problems and for the improvement. After that, then we go to the South China Sea to do the design depth sea trial test. We hired a newly built mothership called Zhu Haiyun and carried out altogether 6 different dives in the South China Sea. 2 dives successfully reached 2,000 meters, and it shows the submersible. All the systems can work properly in the South China Sea. So we just we finished our team flying this all the new team. They spent about 2.5 years to finish the project. Yeah, that's some of the videos taken in the submersible during the sea trials. It will show basically the fish can swim like the mantle leg, use the wing. So that's all what I wanted to introduce in this presentation. And thank you for your attention.
Thank you very much, Professor Kui, for such a interesting talk about sharing with us the history of submersible in China, in which Professor Kui has been playing a very important role, I'm sure. Thank you very much. Going ahead with our program, I have the pleasure to call Miss Laila Abdelrahim, is a senior engineer at the international company Subsea 7. Is a very important player in the oil and gas sector with long expertise in submersible operation, and she'll talk about the submersibles and the project Blue Ocean Research Alliance, BORA. Please, Miss Laila, it's your time.
Okay, so good morning, everyone. Professor, I would like to start thanking you and the organization for the invitation on behalf of Subsea 7 so that we can present our Blue Ocean Research Alliance, which we're very proud of it. I'm having issues here changing from this presenting mode because, so I need to stop sharing, okay, and remove the full screen so that I can, try again. My apologies for that. Right. Okay. So can you see me now, full screen?
Yes,
Okay.
go ahead.
Okay. So thank you for the opportunity again. Just a little bit of who we are so that, you know, everyone gets to know us. We're Subsea 7. We're global leaders in subsea engineering, delivering of projects, since engineering through procurement, construction, installation, and even decommissioning. We are involved as well in our strategy to deliver support energy transition to our clients, to the industry. So we deliver low carbon oil technologies as well through our alliances and some renewables opportunities as they become available in the market. We are in our strategy intending to install them as well, supporting energy transition. So I would start. Sorry. Sorry, I've been noticing here that you're not seeing the correct screen. Is that right?
We are seeing the screen which says our sustainability priority progress. Is
Okay,
that
but
right?
is it full screen? Is it full screen?
It is full screen, yeah.
Okay, so I believe my colleague here wasn't right. Okay, so having said about a little bit about who we are, we became signatories of Subsea 7 became a signatory of Global Compact in 2019, and since then we have developed a strategy, right, for a sustainability approach to the business based on our materiality assessment, where we cross our main risks and opportunities in the business with internal and external stakeholders' interests. Based on that, we have chosen some of the 17 ODS, and based on those selections, we have set 6 main priorities. 3 of them related to the environment, 2 to social, and 1 to governance. So to the environment, we have energy transition, operational eco-efficiency, and ecological impacts. And under the ecological impacts, we have some recycling and plastics initiatives, which are one of the first chosen ambitions that we should manage and protect the environment related to those areas. And we had the ambition since 2019 to set an alliance with a recognized research center among many of those that we have in the world, and some of them are here with us today. And then we created a Blue Ocean Research Alliance with NOC, National Oceanography Center in UK, right? The main objective of this alliance is to enable, through our assets, which is a fleet that operates globally, vessels fleet and ROV fleet, provide access to science to areas, remote areas where they would still reach, but not as easily as we can do supporting them, right? So this will be the main subject today. So I start with a video, right? And then we keep talking. Okay, so back to the alliance, right? So what is this alliance about? It brings science and industry together once we support them, enabling a greater global access to scientific research and advance of global knowledge to benefit society. So the main idea here is really, with data that we collect and projects that we develop together with NOC, we have the opportunity to enhance global knowledge and access to data and support science. So the value to science would be like a huge lack of global ocean observations once we operate, all over the globe, covering over more than 70% of the ocean. We need to increase knowledge in data sets for monitoring and identifying changes in the oceans, increase knowledge of biodiversity and marine life, with some of the projects that I will present later, produce scientific papers with the results and share the knowledge with scientific communities. Once all the data that we collect, we provide with no cost to stakeholders that are interested in the data. So we treat them and put them available to society for free. We can influence policymakers for sustainable decisions once we collect relevant data. And so this alliance will be addressing lack of data, using Subsea 7 global and deepwater reach, working in areas rarely visited by scientists, right? So here's a little bit of NOC site in UK and its capabilities. We have lots of specialists here in submersibles, so I wouldn't take a risk as an environmentalist to go deeper in all this equipment. But we use this slide to show that even with all these technologies, NOC would have one vessel and this technology to launch to the sea, as well as ISIS ROV, right? And it goes deep to 6,000 meters, collecting data and supporting their researches, right? So when they connect to us in this alliance, we have more than 120 ROVs in our fleet. These ROVs don't go as deep as ISIS goes, but because they reach up to 3,000 meters. But still, as we have so many and we can put technology on board ISIS to assess data, we can even raise some 300 times more data than nowadays NOC would collect, not taking part of the alliance, right? So here's a little bit of the areas that we can reach and collect data with our ROVs with their technology installed on it. So together we develop new projects, right? And we start presenting here a BoraBox. BoraBox trademark is a set of sensors developed by NOC to collect environmental ocean variables, essential ocean variables related to climate change impact assessment in the oceans. And they come and install these sensors in our ROVs, and then we can reach remote areas, as I said. So we have a prototype trialed since November 2021, sponsored by BP in west of Shetlands on Normand Subsea, successfully sending data back to NOC. And it's uninterrupted data sharing. Second unit was fitted in the last quarter of 2022 on 7 Pacific, which is a vessel in Brazil operating for Equinor, and sending data back to NOC successfully as well. A third unit fitted at the beginning of this year in 7 Falcon with Aker BP as a client in Norway. And the commitment is for 8 more BoraBoxes to be installed and deployed globally from June 2023. So our main objective in the end is to have across our fleets sensors installed assessing data all over the globe. So the main process here would be in alignment with our clients, because we should never collect any data in their fields without their authorization and support. So we connect to them, get sponsored by them as well, and together we install equipment, launch ROVs, collect data live and uninterruptedly, so that NOC could receive this data remotely, process it, and make it available in a link to any interested stakeholders, other scientists, global organizations, or any stakeholder interested. Besides BoraBox, we have some parallel ocean research projects, right? Tailored specific projects that we can work with clients. So depending on their commitments and their own sustainability strategy, we can develop like biodiversity projects, acoustic measuring, microplastic degradation projects, or any that would make sense for our clients and for us assessing impacts in the oceans and supporting science. So globally now, we have many opportunities being developed still. So we have Black Sea Canyon Flooding Project, Senegal Deep Sea Canyon Acoustic Project, Eyes in the Ocean, which is collecting images to support biodiversity researches and strategies, sediment sampling projects, nature inclusive design, technology collaboration, marine robotics, supporting NOC on their development, events and NOC visits opportunities with our clients once they join us, and other partners that would support the alliance. And one of these examples is that we attended OTC 2023, sharing a part of our initial results. Here in Brazil, besides BoraBox being installed, we have a biodiversity project, which NOC was connected to IFES, which is the Federal Institute in Espírito Santo, to protect triggerfish, which is an endangered species, very important to local fishermen communities. So we intend to support local scientists to reproduce them in the habitat, their original habitat, so that we can protect the species, support them protecting the species, right? So this is another opportunity in Brazil. So closing my presentation today for us all, we have sustainability priorities, so Bora can support clients on their own sustainability priorities and ours. This alliance strengthens the approach to work in a world where we can lead scientific organization, gain valuable scientific data on these essential ocean variables, biodiversity, marine mammals, and any other relevant information to science. We do stakeholder engagement and support local content. Once we support local research organizations and other stakeholders in the country, as we could connect NOC to local scientists in local projects. We build pride because we are taking science with us in every area that we venture with our operations and projects, and our workforce by themselves are very proud of that, and we have their full support on this initiative because it's it's extra work for them. So they would never mind, and they're very proud to be part of it, to do it together with their own regular work scope. And there's wider scientific value being provided with this data collected. Once we accumulate enough data, we want to publish research papers with NOC, supporting policymakers and other interests with this research. And data will be openly accessible and for free to scientific community and any other stakeholders. So we believe this is a very important step with many further results and opportunities that may come from that. And Bora was accredited in June 2023, and we're very proud of that, by UN Decade of Ocean Science for Sustainable Development. So we're now recognized for that by United Nations, and we're aligned with clients and any other stakeholders that would intend to join us supporting this alliance. So that was my main message to all of us here, and I'll be available in the end for conversations and some questions. Thank you so much.
Thank you very much, Ms. Laila. It's very interesting and a clever and efficient way of exploring the deep sea to put together industrial initiative, industrial action that you need to do to explore your business together with the scientific organization to put forward data and important information about relevant aspects of the deep sea. Very interesting.
Thank you for that, Professor. It's our pleasure to be here sharing that with you.
So next presentation will be given by Professor Jean Opderbecke from IFREMER, Institut Français de Recherche pour l'exploitation de la mer, IFREMER in France. And I think Professor provide us with a recorded video, which will be presented in the to us. Professor Opderbecke has got his PhD degree from École Normale Supérieure de Cachan in France. He joined the French Institute for Oceanic Research, IFREMER, in Toulon, France, as a research engineer in 1994. His professional experience includes fully automatic integrated navigation system of IFREMER's deep submersible Nautil and Victor 6000. He is now in charge of IFREMER's AUV project, aiming to developing 3,000-meter depth vehicles. His main area of interest includes signal and image processing applications related to underwater vehicle navigation and seabed mapping. His presentation today will focus the state of technology and operational feedback on the submersible Nautil. The record presentation.
Hello to everyone. A big thank you to the organizers for giving me the opportunity for this talk. I am Jan Opderbecke, head of the Underwater Systems Unit at IFREMER, the French National Institute for Ocean Sciences. You will probably recognize that I have slightly revised the title of the talk, and here is why. I understood a particular interest of this workshop in manned submersibles, and so proposed to give an update on the manned submersible Nautil. Learning more about the scope of the workshop, I enlarged the topic, including recent work on a new autonomous robot named JULY19. As we will see, the joint use of an autonomous robot and a manned submersible make for a very efficient setup for exploration of the deep sea environment. We will see all this in a few minutes. Before we dive into the topic, we'll have a look at the larger picture. The vehicle systems and operations I will present are placed within the framework of the French Oceanographic Fleet. This entity provides naval means and technology for the national scientific community. It is managed and operated by IFREMER, funded by the French government. The French Oceanographic Fleet possesses 12 research vessels, 4 of them blue water ships operating worldwide. On the plot you see in yellow the locations of scientific expeditions over the last 30 years. France has the second largest exclusive economic territory, hence you see expeditions in all major oceans, the Atlantic, the Pacific Ocean and the Indian Ocean. The fleet possesses also 6 underwater vehicles operating down to 6,000-meter water depth, and most of them are designed and developed in-house. Nautil and JULY19 are part of this fleet. Here is an overview over the complete range of underwater vehicles. All have their specific technical and operational characteristics and consequently fields of application. Starting from the right side, classic survey AUVs and the hybrid ROV Ariane are limited to 3,000 and respectively 2,500 meters of depth. These can be operated from our small coastal research ships. Ariane is a unique design based on a battery-powered vehicle linked to the surface ship by a very thin optic fiber. From center to left, you see our 6,000 meter rated big ocean vehicles. The manned submersible Nautil will be object of this talk. Victor 6000 here is a scientific ROV with a very rich set of equipment and sensors. And JULY19, we will discover in a minute, is a brand new development with a unique set of capabilities and features. Now let us learn more about Nautil. Designed in the 1980s and commissioned 38 years ago, Nautil takes 3 persons down to 6,000 meters of water depth. With more than 2,000 dives over the years, she has been a milestone for ocean sciences in Europe. On the left side, we see a picture of Nautil with a titanium sphere in appearance. The sphere has an entire interior diameter of 2.10 meters. It holds place for the 3 occupants and is stuffed with electronics and vital equipment at the same time. 2 persons are lying on short benches placed just behind the 2 lower bull's-eye windows. The scientist is placed to the right and the pilot on the left. In the center of the sphere is the co-pilot sitting on the only seat. He is responsible for communications with the surface, supervision of energy, navigation, sensors, and video recording. He also controls the oxygen CO2 mixture that allow the crew to breathe in such a small volume. In the history of Nautil, there is this specific event which was the discovery of the Titanic wreckage. The American sister submersible Elvin was the first to discover Titanic. Nautil was present in the same expedition and did the second dive down to the site at 3,900 meters below the sea surface. A few years later, Nautil was used to bring a large 10-ton piece of Titanic's hull back to the surface for exposition in a museum. On the scientific side, Nautil has been a major actor in the discovery and research of hydrothermal vents. Hydrothermal vents are volcanic sites where the gas or liquid outflow builds up large structures of sulfur and other metals and rare earths. They provide heat and methane, which combined give the conditions for life, even in the absence of light. This discovery has revolutionized the understanding of biology and the generation of life in particular. The obvious question is today, does science still need human presence in the deep ocean? Most of the research work could effectively be done with the remote operated vehicles or ROV, but numerous scientists worldwide in Japan, China, the US, and France consider that the human presence and the situational awareness in a manned submersible is an unequaled added value for scientific exploration of the unknown. Some numbers. Nautil is 8 meters long, 3.7 meters wide, and 2.7 meters high. She weighs 19 tons in air. When diving, of course, the vehicle is neutral in the water thanks to 9 cubic meters of syntactic buoyancy foam. Nautil can carry more than 200 kilograms of scientific equipment and samples from the seabed. The energy stored in batteries is sufficient for 10 hours of operation. Of course, there is an emergency battery for several days of survival condition. Communication with the surface relies on an acoustic telephone, including digital text messages. Of course, there are powerful manipulators, one stronger and the other suited for precision interventions. Both can lift 100 kilogram loads at straight arm length, which is close to 2 meters. A retractable basket below the sphere allows to carry equipment or seabed samples. Scientific data and observation need the best possible geographic positioning. Nautil features an optic inertial unit and additional sensors in order to locate data to a few meters of accuracy only. Even if scientists have direct view through the bull's-eye windows, they need to bring back visual data to the surface. This is done by 4K video cameras and a high-resolution still photo camera. LED projectors provide 6 kilowatt of light power, giving visibility of up to 20 meters. A dive in Nautil is about 8 hours in length, with 5 to 6 hours maximum time on the seafloor. In that time, Nautil can travel about 10 kilometers at 2 knots of velocity. In case of emergency, the Nautil has a survival duration of 120 hours, which we have never experienced and hope never to happen. The video on this slide narrates the deployment and dive of Nautil on a multidisciplinary expedition named Hermine in 2022. The aim was to search for unknown hydrothermal vents in one of the French permits accorded by the international seabed authorities. Hermine happened on the mid-Atlantic ridge zone. The aim was also to characterize geological structures and evaluate useful mineral resources. In addition to that, scientists ran biologic observations and analyzed the deep sea ecosystem. In fact, one of the missions of Ephemer is to produce knowledge permitting to evaluate risk and durability of human activity in the deep sea. We hence need to understand the environment that we wish to protect. The pictures to the right show a cold water coral colony, an active hydrothermal vent, and the process of rock sampling using Nautil manipulators and the retractable basket. We now reach the second part of my talk, introducing the second protagonist in Ephemer's deep sea vehicle fleet. Since the arrival of the first generation of survey AUVs, the joint use of autonomous and manned vehicles has proven extremely efficient. Nautil is the perfect tool for exploration, but it has only 5 or 6 hours of working time on the seafloor in each single dive, meaning per 24 hours. The detailed topographic mapping carried out with an AUV provides submetric maps of the area in advance of Nautil's dive. From these data, we can determine the most promising features and dive right on the spot without losing time for long search strategies. The gain in efficiency and expensive ship time is enormous. In the picture upright, you see Nautil and Asterix, the AUV Asterix, on board a research vessel. But here we were limited in depth. Accordingly, we set out in 2015 developing a new AUV for operations down to 6,000 meters. The AUV is operational today. It was named JULY19. Here we see JULY19 on board RV Pourquoi Pas during technical sea trials. JULY19 has a unique set of features built around a dual maneuvering concept. The aim is that JULY19 can carry out large area acoustic mapping. This usually means to navigate at optimum velocity at several tens of meters of constant height from the seafloor, following the relief, and then go over into a zero velocity hovering mode, approaching the seabed at only a few meters in order to take well illuminated still photos at more or less 5 meters of range from the seafloor. The optical imaging capability in hovering mode provides visual ground truthing even in rough terrain, and this is a key feature on JULY19. As a 6,000 meter rated vehicle, and with the purpose of producing multi-sensor data sets within the same dive, JULY19 is quite a big AUV. It measures almost 3 tons in a compact 4.5 meter length form factor. It has an electric autonomy of up to 36 hours. The basic concept of ULIX relies on two distinct navigation modes. One is long-distance cruising at 3 to 4 knots of speed with constant altitude, and the second mode is hovering close to the seabed at low velocity. In order to achieve this, ULIX possesses a twin main thruster system. In the standard cruising mode, thrusters work together with 4 steering planes in order to control heading, pitch and roll angles at constant speed. Depth and altitude control is indirect, using the forward inclination or pitching angle of the vehicle in order to follow relief of more than 70 degrees. In hovering mode, the steering planes have no effect. Here, the twin thrusters operate differentially in order to control the heading angle, and 2 vertical thrusters are used for direct depth control. In order to work satisfyingly close to the seafloor, ULIX possesses a reversible water ballast, allowing to adjust the apparent weight and achieve a neutral balance. The payload equipment are activated in function of the range to the seafloor and the operating mode. ULIX is capable of detecting targets on predefined criteria and uses such detections in order to interrupt a mapping survey and decide on itself to inspect local spots with the imaging tool. With these capabilities, ULIX can carry out intelligent exploration missions. Together with the functional richness come numerous payload equipment. The most used, but also the most complex equipment to integrate, are composing what we call the permanent sensor suite. They are listed on the left side. We have the generic sensors, such as the CTD probe for physical water parameters, current profiling with the ADCP. Then the most important mapping tool is the multi-beam acoustic echo sounder, producing high-resolution topographic maps. And finally, the optical still photo imaging system with its flashlight source. Each scientific project having its unique needs, ULIX provides a modular payload bay in the front section, where a set of equipment from a long list can be installed and interfaced. Various physical and chemical sensors are interfaced by a multi-sensor hub. Then we can fit a synthetic aperture sonar for detailed acoustic imaging, or a sediment profiling sounder, and the modular bay can be adapted to numerous new tools in the future. Design and subsystem development of ULIX started in 2016, and the AUV was put into the sea for a first dive in 2020. But then follows a long road of troubleshooting, tuning, and validation. Even if each component has undergone qualification in the pressure tank and integration tests have taken place in the shop and in the seawater tank, a lot of details show up only once you are diving. Navigation issues, time stamping of data, thruster errors, and so on and so on. Especially the robotic behavior and mission control need a lot of dives to get tested. Remember that ULIX is an autonomous system. You can analyze results only after the dive, once the vehicle is back on deck. Testing at depths at more than 4,000 meter water depth requires a lot of ship and personal time. Simply getting to such remote areas can take 1 or 2 weeks alone. To date, we have accomplished 6 test cruises, and we have had the first scientific expedition in 2022. In the timeline, you can see the scheduling of the sea trials, each time with sufficient spacing for corrections and new preparation. The below diagram shows the dive depth over dive number, and as we have not yet worked down to 6,000 meters, ULIX already has a very serious track record of depths above 4,000 meters. In 2023, the aim is to commission ULIX to the operating company of the oceanographic fleet. Amongst the most challenging functions to tune for reliable work is the terrain following. JULYX uses acoustic soundings from a forward-looking sonar, from the Doppler velocity log, and from the multi-beam echo sounder, integrating a terrain model in real time. JULYX is inherently unstable, which gives him the ability to climb slopes of more than 70 degrees. In practice, this comes close to the vertical. The examples on this slide show very steep relief, followed and mapped by JULYX. In such environments, the acoustic sensors are working out of their comfort zone, meaning out of the nominal working conditions, and produce a high rate of outliers. We implemented deep learning algorithms on JULYX that have proven very successful in filtering data in real time. Only when the real-time terrain model is reliable, the autonomous piloting algorithms can do their job properly. Topographic mapping allows to recognize details of less than a meter in size. This is fundamental data for exploration work. JULYX is capable of producing up to 50 square kilometers of topographic multi-beam mapping in one dive. But scientists would be frustrated if we stopped there, as we will see on the next slide. As seen, JULYX has the ability to hover close to the seafloor, and we will now have a look at the first datasets from the sensors used in this condition. The trial area is just out of Toulon in the Mediterranean Sea, where it happens to be the wreck site of an ancient vessel of the French King Louis XIV. The ship, called La Lune, the Moon, shown in the small insert, sank in 1664. Nothing is left from the wooden hull, only metallic objects, like all the cannons, lie in perfect order on the seafloor. The greenish image shows bathymetry. The elevation of the wreck site is hardly noticeable and does not exceed 20 centimeters. In the acoustic intensity image obtained from the synthetic aperture sonar, the objects on the seafloor can be distinguished. The optic images taken by JULYX successively while slowly moving over the seafloor are composed in a photogrammetric three-dimensional reconstruction. The present example lacks a bit of contrast, but this is a real optical map, geographically positioned and dimensioned. So we have seen that JULYX produces large-scale topography at metric resolution and then closes in to finer and finer resolution down to almost millimetric pixels. And the span of scale and resolution is a powerful addition to the intervention capabilities of the manned submersible Nautile. We have come to the end of this talk. I thank you very much for your attention, and I'll be happy to answer any questions.
Thank you very much, Professor Jan. I was really impacted by the thought about thinking on 6,000 meters. What the depth is? It's an amazing record. Fantastic. Thank you very much again. And now going ahead with our program, I'd like to call engineer Art Hedge Olsen from Kongsberg. The engineer Art joined the Kongsberg Maritime as a sales manager for the Americas in 2001. Since then, he has held several positions with the Kongsberg Maritime, reaching the position of Vice President of Sensor and Robotics Sales. He currently works with the Marine Robotics Sales in America's Houston office. So please, Engineer Arndt Hedge.
And can you hear me?
Yes.
And you can see my screen, yeah? Just want to make sure.
Yes, it's okay.
Thank you so much. Yes, my name is Arnt Olsen. I am Norwegian. I work for Kongsberg Discovery, and I'm based here in Houston, working with the Americas, both North America and South America. If you should have any questions and want to talk to me about anything later on, you can note my email, aols@kd.kongsberg.com, and email me if you have any questions, please. I know I have a short time, so I'm going to push on. I will talk about the new Kongsberg entity that's called Kongsberg Discovery very shortly, and then also show where we are now with the AUVs, the autonomous underwater vehicles, and the improvements we have made since last time we presented for you 9 years ago. I will talk slightly about Hugin Endurance and the Superior and Edge vehicle, and also touch into the software we use with the vehicles and have some examples at the end if we have time. So 9 years ago, these are some slides from back then. You can see 9 years ago, we had several vehicles we presented to Cembra, the Remus and the Moonin and the glider vehicle. Those three vehicles are not longer in the Kongsberg scope. The Remus and the glider is sold to another company in the US called Huntington Ingalls. The Moonin is replaced by a new vehicle called the Hugin Edge, and I will touch back into that. And a lot of things have changed since last time. Kongsberg is now split in Kongsberg Maritime is split in two. The underwater part of Kongsberg Maritime is now called Kongsberg Discovery, so that the Kongsberg Maritime department is working more with the vessels and the floating systems, while the Kongsberg Discovery part of the group is focusing on sonar system, fishery, underwater vehicles, and anything that goes in the water, underwater. We have 4 different vehicles we are now working with instead of the other vehicles you saw earlier. What you recognize is the mid vehicle, is the standard vehicle that you saw the last time. And since then, we have introduced another vehicle called the Superior. And we have introduced a vehicle for shallow water for 1,000 meter called the Hugin Edge. This vehicle replaced the Moonin from 9 years ago. And the last year, we also introduced a new extra large AUV. I will touch into that later on. It's called the Hugin Endurance. First of all, the main improvements that has been done on the Superior vehicles is that we now are operating with a dual SAS system, a dual high SAS system on the vehicle. This means basically that on the vehicle, we now have a double length receiver array. That means that we can operate faster and collect data faster with a wide SWOT. We also collect SAS bathymetry data now with the SAS, so that the whole SWOT also has bathymetry together with the nadir, where we use a multi-beam system. We have also improved on the battery systems on board. We can dive for 90 hours. Efficient operation are typically around 72 hours at 6,000 meters, of course, covering now 4.5 square kilometers an hour collecting data. You can imagine how much that is. It's very, very fast compared to other vehicles we had before. To the standard vehicle, we are now operating about 1.8 times the standard vehicle. We have introduced new navigation system. It's called Sunstone, that replaces a NavLab. And we also running displaced face center antenna micro navigation to improve navigation. On the software side, we also run in-mission processing processing image from the SAS and multi-beam and the camera if that is operating. Of course, through the emission processing, we're also improving navigation together with the DPCA. We have extra detection in the water column and also collecting water column data on the multi-beam. Topside tools, we have a new SAS processing system called HiSAP that replaces Focus and Nexus. And we're also running Sunstone NavLab on topside to work and clean navigation data. Other things, subsea LARS, we have developed a new system, a LARS system where you can deploy the vehicle through a moon pool, through rails on the moon pool and over the side, on either side of a vessel, down to about 15 meters below the surface where you release it, and also recovering the vehicle at depth so that you leave the back deck open for other things. New cameras with a wider aperture opening. We also have a new laser with dual scan and new buses in the vehicle. So the main improvements in the superior vehicle is basically changing all of the systems to the state-of-the-art systems possible. Here you can see the Hugin Superior. Hugins are delivered in 3,000 and 6,000 meters now. We have stopped the 4,500 meter vehicle because the design between 4,500 and 6,000 is very close. So it makes no sense to make 3,000 for 4,500 and 6,000 altogether. It's only two now. Also on this slide, you can see the SAS system more in detail. This is the transmitter, and you can see the interferometric SAS system where you have a dual length receiver arrays on both sides, of course. Vehicles are very similar to before. We have control systems in the back, IMU and DVL for navigation. We carry a sub-bottom profiler, one out of 3 different systems, different frequencies. We have a camera and a laser with LEDs. We have a dual HiSAS 1032 system. For looking down, we have the multi-beam system, the EM2040 Mark II. We have a forward-looking sonar for and an altimeter. We have a new removable payload and storage unit, a NAS disk. Now we are carrying 15 to 20 terabyte disk capacity. In the surface, we have GPS, Wi-Fi, RF, and marine broadband radio. We carry a magnetometer. We have a bay in the vehicle for chemical sniffers or environmental sensor sniffers. And of course, a new type of battery that carries more capacity for electricity. We have now increased to 68 kilowatt hour in the vehicle. And we also have a link at the back for modem and for communication to the vehicle through a system called HiPAP, manufactured by Kongsberg as well. Some slides from the side, and then also from the top you can see the acoustic links. Environmental sensors have an opening for pulling water into the vehicle, and at the bottom you can see the multi-beam system, the LED and Doppler and camera and the laser system. A quick look inside of the vehicle. This vehicle is a flooded vehicle. We are using 2 titanium spheres, one in the back that carries all the navigation and the control systems. You can also see the smart motor with 4 fins. In the midsection, you can see the 2 battery packs that carries 68 kilowatt hour. The blocks in between are synthetic foam for buoyancy. And in the front, you can see the payload sphere and some of the instruments that are placed around it. A quick look at what goes on inside of the vehicle. You can see the top side first, where we have a Hugin operator station, what we call the HOS, where you are setting up missions and planning the vehicle's operation. We also have connection with the acoustic positioning, talking to the vehicle if you're following it. We have a RF for the surface communication. We have an acoustic link. Of course, also we have a battery charger on the top side, and we have tools for looking at the DTM, the digital maps, and setting up new missions. Also on the top side, we have a software called Reflection, where we are doing the post-mission analysis and processing the SAS data when it comes back. Below in the vehicle, like you saw earlier, we have a control and navigation processor in the back sphere, where we talk to the top side, control the vehicles, motors and rudders, emergency systems, and all of the navigation sensors that goes into the system. And we also have a bus, data bus to the payload sphere in the front, which is also connected to all of the sensors that we are carrying: the sub-bottom, the multi-beam, the SAS, the camera, laser, and environmental sensors. Inside of the control and navigation processor, you would have a more complex system for navigation. You have the typical INS system that are connected to a Kalman filter, but using DPCA, DVL, bottom track and water track. And we also have a vehicle model here for different types of vehicle. Actuations are controlled. And also, of course, we can use underwater transponder positioning, synthetic LBL, GPS, USBL, surface systems, long baseline, terrain navigation, and the DPCA system. All these systems are typically delivered in containers. On the right side, you see a 20-foot container and a 10-foot, where the 10-foot is a control container, and the back is a launch and recovery container that can go directly on the vessel and be mobilized in typically less than 2 days for testing and setting up. We also have a 20-foot control container that's more normal today, with more room and capability for spare room and server room, and also more room in the launch and recovery container. This is a view from the control container. We have an opening in the back, of course. Inside you have 2 rooms, the server room in the back, and you have the control room in the front with air condition and a nice accommodation. The launch and recovery container, you can see from the back inside of the vehicle. Top side hydraulic door that goes up. In the front you will have hydraulic systems, battery charging, cranes, and different things for changing and swapping batteries. So it's a well-equipped system, a turnkey solution. A quick look at the Hugin Endurance. And the Hugin Endurance, as you will see, is a large vehicle. And some of the features you will see is different from the Superior, is that it has some fins in the front for stabilization, because the vehicle is quite long. We also have fold-out thrusters that can push the nose down or up. We at the back you can see a dual propeller. It's turning both ways to stop the vehicle from rotating. And in the front you see a new type of forward-looking sonar that scans in in two directions, horizontal and vertical, building a 3D image as well of the forward-looking image. On the side, you can see some openings for environmental sensors taken in water. And the antenna is 1.2 meters long and has some cameras and other sensors in it, like the Iridium satellite system and other things for communication. The vehicle is rated for 6,000 meters. It's 11 meters long. It's weights about 5 tons, 5,000 kilos. Typical speed is about 2 to 5 knots, and the endurance of this vehicle is 15 days. 15 days. Navigation running on DPCA is now as good as 0.005% of distance travel on the CEP50 scale here. We have a fast charge lithium-ion batteries on board to make the vehicle run for 15 days. And the payload is similar to what we have on the typical superior vehicles. Dual high-SAS, bottom camera, laser, multi-beam, 0.7 by 0.7 degree openings, FLS, turbidity sensors, CTD, and different types of environmental sensors like CH4, CH2, oxygen, dissolved oxygen, magnetometer, and other things. So the main purpose of this vehicle is long range, and I made an example here. 2,200 kilometers will take you from Rio de Janeiro to Recife in one dive. This is about 2,200 kilometers or 1,200 miles with a navigation performance of 0.01 to 0.005% of distance traveled, using coupling of terrain navigation, DPCA, and everything available as we explained earlier. The other new vehicle is the Hugin Edge. The Hugin Edge is a shallow water vehicle. It's a 1,000 meter vehicle. It's using the same type of forward-looking sonar. It's also designed specifically for autonomous launch and recovery. So it can be launched and recovered autonomous from a USV. On the side, we have a new type of SAS system developed by Kongsberg. It's based on the EM2040. It operates in two formats here with a side scan sonar or an imaging synthetic aperture sonar. It has the typical and same type of sensors on board for navigation and sensors. The difference is the size, basically, where a quick look inside here shows you that we don't use the spheres for navigation control and the payload. We have more cylinders in the front and the back. So the batteries that goes into these cylinders and the concept is slimmed down to a smaller format. And the vehicle size is only 4 meters long, 35 centimeters in height, and weighs about 400 kilos. Endurance is about 24 hours. The navigation on this vehicle is slightly different from the endurance because it doesn't have the same type of SAS system on board. We have a fast charge batteries, and we do side scan sonar, upgradable to SAS, ultra high resolution multi-beam facing down, low light cameras, of course, and we can also swap the camera system with a sub-bottom profiler. Typically, you wouldn't use sub-bottom at the same time as camera, so this is swappable. And of course, automated large systems for smaller boats or USV operations. New also since 9 years ago is our topside system operator station, where you control and operate the vehicles. Typically you will use two screens. One is a vehicle control and command, where you have all the events going on in the vehicle, like battery and RPM, controls coming back to the vehicle if you are in semi-operation, semi-autonomous mode. On the other screen, you would use to set up the mission. We have also introduced something new called a goal-based mission planning. A goal-based mission planning is where you just define a block, an area on the map, and the vehicle.
Please, you have 5 minutes now.
Okay, thank you. And the software will by itself figure out the lines and the start and stop of the lines, how to cover this area. Another example where you also have a USV and cameras coming through, and you can operate several vehicles at the same time with the software. When the data comes back, we run the data through the post-mission analysis software called Reflection, where you can overlay all of the sensors in one image. In this example, you have SAS, multi-beam, and camera showing right now. You can also see where the vehicle is turning on a DTM map. Also on the side, you have sub-bottom, and I have some camera images here as well. It's all about the data. So what you bring back, even at 6,000 meters, we can bring back 5 by 5 centimeter images of the seabed, 5 by 5 centimeter. And this is a wreck of an ammunition ship sunk during Second World War in very, very high detail. We can zoom in on any of these obstacles here. Another image of a cable over a coral reef. You can see the free span with the shadow here very clearly. So, in this image, you see bathymetry of a submarine was sunk and cut in half. So the blue is the bathymetry. On the side, you see the image from the SAS in 5 centimeter resolution, and you see the back of the vessel here, and the front is separated and further away, so it's not shown here. Another image where you see the high SAS bathymetry fused with the multi-beam looking down. Another point cloud or in millimeter detail with the laser, or looking at a free span on a pipeline. And the pipeline is only 35 centimeter. Sub-bottom data. And 3 different types of sub-bottom: 1 to 6, 2 to 16, or 4 to 24 kilohertz for whatever mission you're looking at. The laser profiler and the color camera now with very high aperture up to 48.5 degrees. You can also look at your environmental sensors in the reflection software. In this image, you see magnetometer. And up to the top side here, you see the submarine coming up with very strong colors here for the magnetism. Color camera, 48.5 degree opening, typically surveyed at 5 meters height. The main thing with the vehicles are improving everything about the vehicle, from the operation, safety, topside, the software, launch recovery, and the post-processing of the data, making it faster, easier to use. We are now covering 59 square kilometers in 13 hours and 7 minutes. You can cover 258 square kilometers in 60 hours. That means one typical dive of a superior vehicle. So that has been the main purpose of improving the vehicle, to get efficiency up and covering more and make the data better and more accurate. I think this is the last slide with another fused image. I think I am within time here. Yeah. So Carlos, I think I made the time.
Sorry, thank you for your participation, Ante. I was impacted, very impressed by the capability of a huge AUV at the point that the new version for 1,000-meter depth is considered shallow water. It's how technology goes accelerating. Thank you very much. Next and final presentation for today morning is Dr. Bazaki Mukhopadhyay. He is at present Deputy Director, the General and in Marine and Coastal Survey, Mangalore Geological Survey of India. He is a senior researcher in tectonics, geophysical data interpretation, earthquake geology, statistical seismology, and earthquake-related natural hazard prediction. He took graduated studies on applied geology and mineral exploration from the Indian School of Mines in India. So, with the word, Dr. Bazaki.
Thank you, Professor Levy. And I think I am audible by now. Am I audible?
Yes, we listen to you.
Okay, thank you. Thank you very much. A very welcome from Geological Survey of India and one wishes from India to ladies and gentlemen who are present over here. We usually greet with a namaste with a folded hand, and that is what I am doing right now. I am basically an odd man out in this particular session. In this ocean of technologies and engineers who are actually presenting the capabilities of the ROVs and how they are doing the things. I am in the other part. I am a geologist, not a technologist, but using some part of this instrument to our exploration. And I hope that this is a knowledge gathering session for me. I'm extremely delighted to hear that how the technologies has been developed in this particular field for the ocean exploration and the mineral exploration we do in the ocean for the non-living objects. So basically, it is a knowledge gathering for me, and I will go forward with my presentation. In Geological Survey of India, we are operating in both in the land, in the sea, as well as from the air. So I am a part where we are operating from our sea part. Basically, we are having 4 zones over here on which we work. It is in the near shore. We work for the 0 to 10 meter water depth with the survey mechanized boat with a very rudimentary facilities of sub-bottom, your multi-beam taking data and some of the sampling devices, mostly grabs, to take the samples from the top part of the ocean. In the territorial water, we are basically having 2 ships owned by GSI. One is working in the west coast of India and another is the east coast of India. The Samudra, Arabi Samudra, Sodikama and the Costa. which is operating from 1984 onwards. Last 40 years, we are working with these particular two vessels. And we have done 245 and 237 cruises with this. Mainly the baseline data generation and exploration cruises. And then we go to the contiguous zone, the contiguous to the territorial water. It is 24 nm and with an area of 236,000. These are also operated by these two coastal vessels. And then in the international water and exclusive economic zone, earlier from 1983 to 2013, where we have done with the Samudra Manthan with 216 cruises. And presently we are doing with the Samudra Ratnakar, which is done in 2014 with 64 cruises. We are doing this with the international cruise. Summing up that we start our modest beginning in 1960s, those we are having an organization of 170 years in existence, and the second largest the survey in the world after British Geological Survey. And then we have the starting with 1983-84 with our coastal vessels and the ocean-going vessels. Until date, we have done 762 cruises for mineral exploration within the exclusive economic zone of India, basically creating the marine geoscience data and the exploration-related activities. To summing up over here, the seabed mapping and data generation we are doing, and from there we are creating an area which is called the offshore prospective area, where we are doing the mineral exploration for different commodities. And from there, we have done the resource estimation for the HM glaciers and the construction sand in territorial water, and a vast resource of lime mud in the exclusive economic zone within India. We reported the occurrence of the polymetallic sulfides, phosphates, and FeMN crust and nodules within the exclusive economic zone of India. Now, this is one of the maps which is showing you the OP areas of the different commodities which you have told: FeMN, heavy mineral, phosphorite, sand, metalliferous mud, hydrothermal mineralization, and the lime mud, which are having in different colors. I'll be coming one by one in the next page. Now, the data which we are basically collecting over here is the basically multi-beam and the single beam data which has been produced with bathymetric map of the Indian EEZ. These are all shipborne data through which this bathymetric map has been prepared. And the sampling that has been done by our sampling device, we are having graph sampler, then the different core sampler, the piston core and other, which has been created the sediment distribution map, which is the right side of the panel, the seabed sediment distribution. The magnetic data and the shallow seismic data, which we are collecting through our vessels. We produce this magnetic map, and the gravity map is also there inside, so that we can predict what the mineralizations are there. Shallow seismic data is basically in the shallow A within that continuous zone only, where we are taking that the images down below up to 30 to 60 meters over there. But in the deep sea, we are having deep sea, the DRS system, which is going for near about 4 to 5 kilometer depth, which we are taking in the deeper part, mostly in the Andaman and the Lakshadweep Sea over here. Now, the right side panel map is actually telling where we are having our mineral deposits, both HM, FeMN, sand, phosphorite, lime mud within our EEZ boundaries. Now, coming to the HM part, as you are seeing over there, the pink part is actually the area where we are exploring our A, and the green part where we have already explored. This part has given 79 tons of the resources of HM, which basically of fusillimanite, rutile, garnet, monazite, ilmenite, titanmagnetite, and zircon. Now, coming to the other part, there is a sector where we are needing the construction sand. Basically, the Kerala, the southern part of India, doesn't have much construction sand on land. So they'll be needing the sand deposits over there. These sand deposits are having 80% SiO2. And there are 4 sectors where the sand deposits are there, amounting to 745 million tons. Now, this is another area which we are doing in the EEZ part, exclusive economic zone. This is the lime mud, the lime pellets, the lime sands, and the lime slurries, which are present in the western coast, that is a part of the Gujarat, and on the part of the Andhra Pradesh, in eastern part of India, in eastern shore of India. We have already done the exploration over there, and the preliminary estimate is 1.53 billion tons of this limestone and lime mud. Basically, this is actually a SMS grade, a steel melting shop lime, which can be, and also the chemical grade, which can be used in different other purposes. Now, this is one of the thing which India is lacking in the land part also, these phosphates. These are the places where the phosphates are being explored by us. One of the prospect is in the side of the Chennai, that is in the southern part of India, where we have done the exploration up to 2 meters below the sea surface, and which gives us the area of 1337 square kilometer with a phosphate content of 14 to 25%. Now, coming to the second part, where so far I was listening to the different technologies that has come. This system is age old because it has been procured in 2013 when our ship came. It is a CI Coger XT1445 ROV system, which is an observational class ROV. It can go up to a depth of 2 kilometers. It has a pan and tilt camera inside, which can take the photographs and videography. There are two manipulator arms. One is taken for taking the samples. Other has been modified to go for a small drilling unit over there so that we can penetrate the surface. And then the forward speed is 3.2 knots, but without any mass sensors over there to go for it. What we are doing with these sensors is actually we are exploring the different parts of the sea mounts where these polymetallic crust and nodules are present, as well as the hydrothermal minerals are in the accretionary present part of our Andaman, which you can see in the right side of the map. And also in the left side, the Lakshadweep ridge, which is also having this type of environment where the deposition is taking place. So we are exploring with this ROV to take the photographs and then part of the samples that has been taken from there and getting analyzed. Now, this is the part which I am talking about the Andaman. It is basically a subduction interface where we are already having the 4 mounts. You can see in the right side panel photograph, the map, which is having invisible bank, alcohol rise, seawell rise, and west seawell rise. In between the west seawell rise and seawell rise is promising, which is giving this FEMM nodules and the crust which is shown in the slides, giving a deposits of manganese 7 to 18%, cobalt from 650 to 2095 ppm with an average of 0.1, that is 1960 ppm. Then zinc, nickel, platinum, barium. Most important is the RDE and the RDE with yttrium. So I do believe that up till now, the instrument which you are using, you will be needing this for the making of the batteries, as well as for going for your steel or other material, which is actually giving you a high pressure equipment from these materials. Now coming to the next part. The next is the other part of West Coast, where this is in the Lakshmi Ridge. That is where we are having this metalliferous crust and the nodules. I am having some ROV photographs over there, which is basically a ridge system which has been developed by the Bloom. And on the top of it, we are having these the incrustations as well as these FEMM nodules over there. We are exploring right now. But these are all the occurrences, not to the deposit or the resource I can tell, because is the percentage of the metal and other content is far less than what we are getting in the open sea. So this is one of the things, but it is one advantage is there. It is near to the shore, so it can be easily extracted and take to the mainland. This is the part. Thank you very much for patiently listening to me.
Thank you, Dr. Bazak. I was quite impressed by the amount of work that India has been doing in mineral research in deep water. I was amazed by knowing that there is so much work up there. Congratulations to. So thank you for all speaker, and now we reach to the phase of the debates. I don't know if Claudia is supposed to say some words first or not.
Olá! Que bom, né? Estar com vocês de volta. Parabéns pelo painel, parabéns a todos.
Hello. Thank you all for the attention, for being here with us. And I was going to give my input as well, because within our schedule, everything is just for us to come up with a debate, a talk among you, all of you, because I believe people might have questions at this point. For those who are participating within the chat, they can start the process now. Thank you, Claudia.
We have a lot of questions, and I will organize by blocks for each one of you, our speakers, and let's make 5 minutes for each speaker to answer the block of the questions. All right? Let's start with the Professor Eduardo Silva. I have a question from Silvia Bellato. He asks you if it's possible for you to leave the name of to let us know the name of the organization, your geological organization, Brazilian Geological Organization, which is working with you there in Esctec. Another question is, which amount of money the UE, the European Community, invests on the development of robots, submersibles, either in Portugal and also in Europe as a whole? And the other question, also from Silvia Bellato, is she wants to be sure that he understood it correctly, that you said that there are 2,000 points of exploration in the deep ocean, in deep sea, in Europe, and there are these are your questions, please. You're mute, Professor Eduardo. You are mute.
Sorry. I ask you for if you can repeat, because you have a problem in the network between Portugal and Brazil, and I lose the network during 30 seconds. Please, can you repeat?
You haven't heard all of them or only part of it?
Oh, no, all of them. All of them.
Okay. So from Silvia Bellato, here she wants to know about the name of the Brazilian Geological Organization, which collaborates with you.
Okay, I need to go to my notes.
Let me say the whole amount of questions. Which amount of money the European Community invests on the development of robots and submersibles either in Portugal and also in Europe in the total. And also she wants to be sure that she understood that you said that in Europe there are 2,000 points of deep water mineral points of explorations.
Okay, the last one is more easy. Okay, I talk in open pit mines. This is flood of mines in land. 2,000 is open pit. Okay, in Europe exist more than 30,000 abandoned mines, but 20,000 is in tunnel and 2,000 is in open pit. Okay, you can find the spread for all of Europe. These 2,000 of type of mines. It's not possible mining all because it's very hard, the rocks, but medium rocks is possible to mining underwater because it's possible to actually the technology of the heads for cutting heads, I can go to 200 megapascals of strength to cut the rocks, and but it's in open pit. Okay, in the sea we don't have any inventory of the place yet. In Europe, the people spend a lot of the European Commission spend a lot of the money in the EUVs or for several type of the application and the project. In the case of my project, the financing of European Commission is near those 16 million of the euros for the project, but is not the full money is not for the robots, is also for the crews, is also for the other people. Okay, in our project for develop some prototypes, in our project is 5 million of the euros, but some robots existing is not we don't the European Commission don't go to pay every robots of our project, only some updates in sensors and some new prototypes. Okay, but is the prototypes is the readiness level of the prototypes is less than 7, is only for a full demonstration, is not a full product. Is not like the robots of the Kreuzberg, or because is a research robots and is only for to prove the concept and so on. But for the first question is to the name of the Brazilian organization, I suppose is a geological survey, but I can go and write in chat. I go to my mail to find correctly the name of the Brazilian organization. I write in chat. Okay, it's better.
Okay, thank you, Professor Eduardo. Let's move on. Now for Professor Cui. The question is, you have again, I will ask, I will said the whole block of questions,
Okay.
and you try to answer in 5 minutes, please. Professor Cui, is there any interaction that you know between technological sector of research, ocean research, between China and Brazil? Another question: the United States has been the question is from Ali Kamel Ismail Jr. The United States has been applying the technologies developed in underwater autonomous vehicles in space explorations, and he mentioned about the link. Due to the fact that despite of environmental difference, the systems have a high degree of autonomy and adaptation that allow logistical and design efforts to be saved. China also uses this kind of approach, is a question. And these are your questions, Professor Kui. Please.
Okay, yeah, thank you. Yeah, got the two questions. And first, I think in terms of the international cooperation between Brazil and China, yeah, as far as I know, in the deep oil company, the oil industry, there are some cooperations for the platforms or something. But for deep sea submersibles, and I'm not aware there's any cooperation between China and Brazil. To be honest, personally, I'm not aware about that. And my own experience, I still didn't know the people in Brazil who are working on the submersible community. And in terms of the AUV autonomy of AUV or something, I think in terms of the technology, there's no much difference between China and United States. We are more or less use the similar technologies. In the development of the JULY deep metal submersible, and we had some technical cooperation, or in particular, there are some equipment are manufactured from international companies, but we met a lot of difficulties in in getting this equipment. Sometimes the government technical blockage or something. So this is not only technical cooperation, there are some political disturbance. So that is why after the success of the JULY deep metal submersible, the government spent another 5 years needed to be solved that all the equipment to be manufactured in China and working on the depth of 4,500 meters. So after the success of this submersible, then we the most sponsored the 4 ocean depth submersible, and all these submersibles are actually developed use Chinese manufactured equipment. So basically, more than 90% of the equipment can be manufactured in China, and now I think we are more or less capable to develop any type of submersibles or something, just based on the technology in China. And there's no much difference, I think, in terms of all this technology between United States or China or other countries. Mm-hmm.
So thank you very much, Professor Kui. The next block of question goes to Miss Laila Abdel. The questions are from Ali Kamel. The question is, in the prospections of the Boras project, the Subsea 7 found difficulties related to the authorizations, official authorizations to get along with the actions, and he would like to know also see the data, the collected data can be accessed to only for clients that pay for the collection, or also they are submitted to analysis for national organization where the missions are developed. Did you get it?
Got it. Thank you for the question. Well,
and there is another one. In fact, there are three other.
May I answer this first one so I don't forget it?
Sure, please.
Okay. So firstly, well, if Kamel is my former colleague from university, it's a pleasure to have him here with us. Not sure if it's him. In case it is, my pleasure, and thank you for the question. In regards to difficulties with local authorizations, not really, because for now we started in Brazil with the sensors, right? The box sensors, and our vessels and ROV is already authorized for environmental data collection. And at first, we're testing the sensors with data that wouldn't be extra data in regards to what we already are authorized to do with our sensors on board. So the authorization for now that we have from local agencies and regulators to do this first assessment, we are good to go for now. And for further and deeper researches, any extra data like images and other data that would be necessary, we would go first engaging with authorities before moving on with the project. And we have a team established for each region and in the globe, so that wouldn't miss any specific requirements, regional requirements. About data availability, clients usually support us in implementing the project, but whenever we collect data, the data is previously authorized by clients to be shared globally. So what we do is that we share data with NOC live through from ROV straight to NOC. They treat the data, connect it to a link, and it becomes available to any party that would be interested in the data. So this would be authorities, research centers, even clients to use them in other studies that they may progress. So it's available to all stakeholders interested in society, mainly. Not sure if I closed.
Okay. The next question for you is in which areas Bora is engaged to the decade of the ocean?
In which areas?
In which areas? If there are any area where the Bora is involved with the actions related to the decade of the oceans.
So probably the question is related to in which subjects were we classified as, well, I need to go deeper on that to revert. So in case I get the contact of the person, I can revert with that answer. But mainly, it's all in regards to, supporting science with data collection and supporting the preservation of the oceans, right? But I need to go deeper on that, to the classifications and revert. So if you share with me the contact, I can do it and revert.
Okay, I will send to you his contact.
Okay.
Nilo Martins asks if on Bora from Subsea 7, is there any insight already about the data from the Brazilian area?
Brazilian area,
in the ocean.
Well, we have installed in with Equinor in one of Equinor fields, where they are mainly the operators and our client in the project. And the data started to be shared with NOC in the beginning of this year. So there's not enough material information for any scientific conclusion, but we are on our way to get there.
And the final question from Maggie Antunes. She wants to know if is there any educative initiative actions involved in the Bora plans.
Well,
to young and young people.
Okay, so for now we're starting the alliance, right? So mainly we started with those projects related to impact assessment in the ocean. We have the intention to connect this initiative with society. So it's an underdevelopment alliance and with corporate decisions on what steps would be next based on our strategy. So for now we have a website where we connect everything we're doing with society. So there's open information there, and it's in the end of my presentation. So whenever we share the presentation with attendees, they will be able to access Blue Ocean Research Alliance site. But if you Google it, it's still there. So for now, we have all this information shared there with society, including any part of it. And maybe in the future, we can engage with some specific awareness to young people and other relevant parts of society. Not for now.
Okay, thank you very much, Laila.
Thank you.
It was very illustrative answer that you provided to us.
Mm-hmm.
And next block of questions goes to Professor Jan Opderberg. And the first question comes from Commander Dagnino, and he wants to know the volume of money from the French government, which is allocated to Inframer to the development, to support the development of a submersible. Also, he wants to know if there are resources, money from the European community, and if the Inframer has a partner from abroad, Europeans or not, and also how many research work at Inframer on the subject of submersible. These are the question for you, Professor Jan Opderberg.
Okay.
Sorry. There are last one, another one. Silva Bellato asks if there are any interaction between Brazilian technology organizations and Inframer in France. These are the questions. Thanks.
Okay, thank you very much for these questions. But the first one, of course, is a tough one, talking about money. It is not an easy answer because the way we run the development, the maintenance, and the upgrading of existing underwater vehicles are all shared in the same team and in the same volume of budget, of funding. And our vehicles have very long life cycles. Unlike industrial products, we have seen Nautil is operating for almost 40 years. The big ROV is operating for 20 years, and so on. And there's a lot of upgrading and adaptation of this vehicle continuously going on for the scientific projects. So these are really living systems. They are not in a fixed and frozen configuration. And for all this, let's say for the upgrading, treating obsolescences and correcting design flaws and so on that come up over the years, there is maybe an envelope of something like 3 million euros per year without personal cost. But this covers all of these, and even some of the maintenance work the operating company will accomplish. When in this process, this is the French oceanographic fleet. It is funded 100% by the French government. But when we have development projects, so I can name the development project of ULIX. For this one, we have obtained funding from the European Union, from the region of southern France, and from the French government. And the part of the European funding was 1/4 of the money we spent. Again, we do not count in this the personal cost of the ephemer team here, which is already paid, if I may say so. Then we come to European partners. Well, there is a big initiative here in Europe, which is called Eurofleets. It started as a EU-funded research project, and the aim was to bring research fleets closer together and to have methods to share the means and ship time. And in this Eurofleets program, we are now in the third instance, this third episode of this project. This year, this third one is piloted by the Irish Marine Institute, and each time there are scientific cruises open to European researchers. So the individual national fleets or operators are paid in order to provide ship time or underwater vehicles whatsoever for European scientists, and they're funded for that. And this is really, still it is difficult because each country has its own mechanisms to steer and govern and plan the use of the scientific research vessels and all the equipment. It's difficult to synchronize between the different countries, but there is this initiative which creates ways to share. But there is still a lot of work to go. But the ocean science community worldwide is so small that we know we have good contact with other research institutions in Europe, but also all over the world, with the Indian institutes, Korean, the American, of course, with Brazil some years ago. So it is quite a small world of people of ocean science. Then there was a question on research personnel. So for the engineering, the group here, Underwater Systems Unit, is around 50 engineers and researchers. And they go from research and development programs all the way to operational systems. And so the research and development work is oriented towards practical results with a horizon of 3 years, roughly, 3, maximum 5 years. So it's not fundamental research, but applied R&D. And then the same team goes down all the way until there is a useful tool for ocean scientists operated at sea. And this is 50 persons. And of course, we work a lot with companies, industry, and there are a lot of companies like Kongsberg we have seen, and Exail in France, and so many others worldwide in order to use technology that is proven wherever we can. Associated with these 50 people are around 40 for the operations in the operating company, and we work very closely together, and all the technical details and observations or problems they experience at sea can come back directly into our group in order to be processed. So have a very short loop from the design, development, field experience, and back into the engineering group. So this is quite fruitful to have this very short loop with the feedback from what really happens and is experienced at sea. The last question was on cooperation with Brazil. And since I talked about the man-submersible nautil, there was a project developing a man-submersible in Brazil, and IFEMER was involved with advice and expertise, possibly even transfer of to local companies and institutes of experience we have here on this behalf. I'm honestly, I must say that since the COVID years, we did not have follow-up on this activity. So I'm not quite sure if this is continued. And then in other areas, we have scientific contacts, and a little bit as we've seen from Laila's presentation, there's a similar thing going on with Brazilian company Petrobras, and they work with scientific institutions in other countries, and they work with ocean science personnel at IFEMER. So this is not in our engineering group, this is in the ocean science community, but there's a quite good established relationship between Petrobras and ocean science experts within IFEMER. So I think I've...
Thank you very much,
I hope I was not too long.
Professor Jan Opperbeck. The next block of questions goes to Dr. Arthur Helge. And the first one comes from Commander Dagnino. He wants to know if there are national institutions in Norway working on the submersible area. Alberto Campos, Mr. Alberto Campos, asks if there are any possibility, or if it is in the horizon, the use of submersibles in universities which have courses with the submersible with that kind of capability, like you described of Hugin, applied in the academic works, or in that sense related to universities. And the next question comes from Silva Bellato. She was quite impressed with the high technology used by Hugin AUV, and she wants to know if there are any applications of this technology in South America. These are your questions. These are all your questions, Dr.
Okay.
Ant.
Yes. So the first question: institutes working with AUVs in Norway, as we are based from. There is a university in Norway called NTNU, Norwegian Technology of Technology in Trondheim, And also in Trondheim, there is they have several USV boats and vehicles they're working with. There's also a government-approved robotics testing area in the fjord outside of Trondheim. So NTNU in Norway is doing a lot of work around cybernetics, robotics, and of course underwater robotics, as well as vessels.
I suppose that SINTEF is also engaged on that kind of work.
Correct. SINTEF and NTNU goes hand in hand most of the time. Yes, you're right. Also, there's other places where they do research working with vehicles. I'm sure. I mean, there is India, and every country has some sort of work going on with this type of technology. It's not just Norway. Courses. Again, in Norway, that would be the place to study any cybernetics or robotics. Would be at the University of in Trondheim, the NTNU. Also, of course, in the US, you have MIT and where they have very advanced robotics courses. For operation, there is not too many schools who teaches people to operate, to be operators of AUV. So Kongsberg, we give a 3-week course on the vehicle, typically on purchase with customers who have acquired them. But anybody can sign up for these courses, 3 weeks long. In South America, there is especially Peru, actually the icebreaker. I think the name of this icebreaker is Curasco. They have 2 AUV systems to be used from the icebreaker. Other than that, there's non-owned vehicle as I am aware of, but the Hugin vehicle has been working in Brazil quite a few times with our customers like Oceaneering, Fugro, CNC, Ocean Infinity, and so forth. So it has been used in Brazil quite a bit.
Yeah. There is another question which comes without any particular destination, but I think you can you can answer it very well. It comes from Márcio, Mr. Márcio Arcifa. He wants to know the communication underwater with the AUV is done predominantly by hydroacoustic way of communication. He wants to know if there are any perspective of using communication by light. That's the question.
Yes, so we operate at 6,000 meters of water depth, and to do that, we use a system called HiPAP, which has an acoustic range of 7,000 meters. So we have a little bit of slant range as well, and not just straight down. We can also go to a lower frequency and reach 11,000 meters on low frequency systems at 12 kilohertz. But for using light is a very, very fast system. And typically it's difficult to reach longer than 500 meters with a laser system in water. So for us, we could use light to harvest data from sensors sitting at the seabed within a 500-meter range, picking up data from those. So we're using light, but for communicating from the surface down to a vehicle, it's not practical. No.
Okay, thank you very much, Dr. Art. The next question go to Dr. Basab. The question comes from Commander Dagnino, who wants to know the budget of GSI, the organization where you work, to to the development and operation of a submersible. He wants also know which organizations in the panel analyzed the advantages and disadvantages of exploring ocean minerals. I think you are very Dr. Bazab can answer that question without any problem. And Dr. Bazab, for Dr. Bazab, the Silvia Bellato wants to know she praised the work you are doing there in India. She was very impressed, very well impressed, and she thinks that it's a little bit scary, also a little bit scary in the sense the one concerned with the environment issues, environment consequence. And she wants to know if there are any zoning delimitation, area delimitation, which are more sensible to this kind of intervention, and if they are protected by the Indian government. Prohibiting mineral activities there.
First question is on operation and development of the submersible, I do believe. That we are not doing over here because GSI uses the submersible for the exploration only. We are the end user. There is another organization over here in India which is called National Institute of Ocean Technology, which is there in Chennai. They are developing submersible in the Indian boundary. So they can be asked to answer this, that what is the development they are doing this. Second is the advancement of the exploration of the ocean minerals. The equipment which we are having right now over there in our system with the bathymetry, the submersible, your sub-bottom profilers, the sampling system, the magnetic and gravity data we are using, and then the shallow seismic and deep seismic zones, along with the ROV, SAS, and side-scan sonar, we are able to detect the places where our mineralizations are. But main problem is when you are going for the resource calculation, which is the part which has to be done by a geologist or the geological community. Most of the cases we can do when we can penetrate that with our system, basically with the vibrocore. Then we can estimate the resources. I have talked about the resources we have calculated. But in many places where we don't know the extent of the mineral and down to the surface, like your FMN crust and the nodules, we are restrained to calculate our resources. We are telling it is an occurrence only. So later half, this thing can be taken care of to understand how much area it has been covering and what is the extent that mineralization is there down depth, so that the resource can be calculated. I am not talking of the reserve. I am talking of the resources. Now, the second part is the environmental part. Actually, no mining is taking place in the Indian offshore today, but in near future it will be coming. And there are zones which is there, defined by Government of India, which is basically the protecting our biosphere over there. So we are not the mining agency. The mining agency will be, we are only the exploration agency. The mining agency will be taking care of these things when the mining will be actually taking place in the Indian oceanic part. I think I have given the answer to the questions which has been asked. Any other has been left out, Professor?
No, it's okay. There is another. It's a question from me. most of the projects in India in terms of mineral exploration have already reached the equilibrium financial point, or they are still in trying to to be profitable
The
or not?
basic thing is the profitability of mining of a particular mineral is the metallurgical aspect of it. How much the metal can be extracted from that mineral point of view. That metallurgical aspects has only been taken by us, by our other organization in the lime mud. And that's why I told in the lime mud, it is the SMS grade and it has been put into the SMS platform so that it can be used in the steel melting shop. For rest of the things, that metallurgical aspect has not been taken care of till date. Whenever the mining will be taken place, obviously the people will be going to that metallurgical aspect and go for this cost-benefit ratio. That is how much you are spending and how much you are getting out of it. And then they'll be going for mining. It is basically the mining people that will be doing. For an explorer like us, survey, we have to explore if there is a zero mineral present over there also. So this is our aim to go for the entire seabed, see where the minerals are there, and the possibility of the extraction of that thing. We will be giving a resource, not the reserve. Reserve will be coming when the mining will be taking place. I think
Okay.
I hope I can answer your question.
Yeah, it was very well answered. Thank you very much. And now I finished this part of our panel saying my most warmest thank you for all the speakers that offered a lot of knowledge on their respective areas, and I think you managed. I was very. I feel that we had quite opportunity to exchange ideas, point of views, and the level of technology that we have at our disposal to face the challenge of braving the deep water of our oceans. In that sense, the panel and I think the webinar as a whole reached its main objective, that was to bring about the theme, the challenging theme of exploring the deep water and to get to know what can be done in benefit of our society. How can we work to bring to the surface all the riches, all the resources that could be available in the seabed? Thank you very much for your qualified contribution to the cause. Thanks. And I think now we have the word of Claudia, our ceremonialist. Please.
Eu gostaria, olá, estou aqui. Eu gostaria primeiramente de
Hello.
agradecer
I would like to, first of all, thank the moderator of our panel number 3, Dr. and Professor Carlos Levy. Thank you so much. Also, I'd like to thank every single panelist who were part of this morning with us. Now, I'd like to open this moment for any comments you might have about this panel this morning, so you can contribute with a few more words, if you could.
Vou falar agora em
Now
português.
I'm going to talk in Portuguese
Tornar mais
to
clara
probably make it easier to show, to express my gratitude, how happy I am to be able to moderate this set of speeches, presentations, because on my end, I received a lot of teaching, a lot of knowledge they're going to be very useful. And I'm sure that this feeling is probably common among the people who are listening to us. In that sense, so I believe they also feel very much satisfied with the positive results that our webinar was able to achieve. So thanks so much, Professor Carlos Levy. Thank you for being with us for this wonderful morning. Now I would like in this moment to invite our executive coordinator for our Cembra, the Admiral Júlio Soares de Moranet, for the official wrap-up of our webinar. Thank you so much, Claudia. So, dear participants of our second international webinar for submersible for deep sea, this braving the deep seas. And good afternoon to everyone. We're getting to the end of our journey here towards a better knowledge or more knowledge of how we can employ submersibles in Brazil and around the world. I'd like to my first few words just to be thank you words, gratitude words for those who made this event possible, for another successful initiative from the Center of Excellence for Brazilian Seas, which is Cembra. I'd like to thank all participants, speakers, everyone who were involved somehow with the organizing and putting together of this event, and especially those who have to do with the entrepreneurship and researchers, teachers, and all the interest parties. Now, as a precautionary measure for those who are following up on this work, but not with so much time to have accurate evaluations, I'd like to just venture into introducing a few points about the evolution of this topic in our country throughout about 10 years. And to be more precise, throughout 9 years, when we had our first international seminar that was previously held under the same topic, and that happened in 2014. So indeed, when we compared the countries in both events showed very clearly the difficulties that we face, especially when the projects are held by the academy. On one side, you have the lack of resources, of funds that impeded the development of science, technology, and that compromised many important research that were going on, especially in universities. On the other side, we have the influence of pandemic of COVID-19 that created and disrupted all the vertical projects and also the projects for submersibles that were not immune to what happened. And also the non-occurrence of industries willing to face the challenge to produce such vessels in Brazil. In the international arena, we might have had some weirdness when it comes to not showing in our webinar any presentations from our neighbors, our continental neighbors. And that lack was, or that gap was because we didn't notice the existence of development, of concrete development of submersibles in those countries, in which unfortunately it doesn't make us any more comfortable, any more happy. So what we noticed, what we could see in some countries was the importance, the key importance of submersibles to the development of our segment. And that explains by the geostrategic interest from each side. Another aspect I'd like to highlight, due to the Titan explosion, and it really impacted all of us, no doubt about it, during a tourist mission to see the wreckage from Titanic, about 1,800 meters deep. So that was the idea of a country to try and establish new standards or maybe new certification for vessels that go through these dives, not only deep dive, but also in other types of diving. So it's possible that the Brazilian naval forces can be part of this process. And after such comments, I'd like to highlight one point, that Cembra, with its pioneer role in talking about this topic, we're coming up with important, significant subsidies. So all of our participants may be well aware of the importance of submersibles during research and exploration of deep sea, of deep sea waters, but other variables that we can use, including the military and naval areas. And I'd like to highlight that Cembra estimates that its submersibles can be object of assessment and future steps towards our country. And now going back to my first words, when I started this talk, this wrap-up talk, it's important to highlight that nothing that was said here was going to be possible without the participation of our respectable, or of our distinguished speakers in their presentations, which I would like to now thank them. And even though we had the panel with moderators that I would like to show my appreciation for. So I'd like to emphasize that I want to say on behalf of Cembra, my truly, deeply thank you for the coordinator, for the Admiral Luis Felipe da Costa Fernandes. And with extreme competency, he dedicated 100% to the planning, to putting together and managing this event. So I attribute to him a huge part of this success that we all were witness of. And just to be fair, he should also get these praises that technical director Carlos will be the members of the committee in coordination. I like also to thank the Cembra team. They made it all possible, who made this event possible, and they didn't hold back on their efforts to make this happen. And therefore, the companies were hired who did it all in a very professional way. They gave the proper support to this webinar. And that wouldn't happen, wouldn't have any meaning without the prestige of our audience who believed in the Cembra initiative. And we'd like to emphasize the importance and how inevitable, how the submersibles are extremely key for the research on the ongoing research in deep sea waters. And I'm 100% sure that they will be indispensable for the future of the life on this planet. And that was the goal of this event. We hope that it was reached. Now I'd like to just highlight that we had a very good number of signups, 165, and participants watching our presentation, about 230 on the 18th by the morning, 190 on the 18th by the afternoon, and 169 today. So at the end, we are expecting that this initiative may have our participants be aware about the importance of sea in Brazil, and also submersibles for research, exploration of deep sea waters. Getting them together, rallying them to be participants in this goal. And for that, Cembra counts with the participation of everyone involved, because once you're convinced of the importance of this topic, they can share this knowledge that were here broken down, but now they can show and spread the message and share in their social circles, as well as other parts that are interested. And for everyone, thank you so much for your time, for our work within the last 2 days. It was a huge pleasure being able to share with all of you our activities. And then now we're getting to the end. So now I declare this finalized, the second international webinar on submersible, braving the deep sea waters, the conquest for future. So wish you all the best. Thank you so much again for your attention.
Eu gostaria,
Cláudia, a palavra retorna a você, tá?
Claudia, the floor goes back to you. Let's go. I would like to once more thank you all for being here, everyone who joined us for the last couple of days for the webinar. And I'd like to wish you all a wonderful afternoon and a wonderful end of your week. And I'll see you next time. Goodbye.